Okay, learning target. I can use substitution to integrate. I'm actually going to use substitution to find indefinite integrals. So looking at the problem, I'm giving the integral of the quantity 5x squared plus 4 raised to the fourth power times 10x, and they tell us it's a derivative because there's a dx there. Now, in order to find the integration, I need the antiderivative, and I don't want to multiply 5x squared plus 4 out 4 times. So there has to be an easier way. So what I'm going to do here is I'm going to identify the inside function, or the BLOP, and I'm going to let that BLOP equal u. So the BLOP is the inside function right there in green. So u equals 5x squared plus 4. I then need to take the derivative of u and of x, and I'm doing this in terms of x. So this is going to be du equals the derivative of 5x squared, 10x, the derivative of 4, of course, is 0, dx, because I am using differentiation of u and x, and I want to solve for dx. So I'm going to get the dx by itself by dividing by 10x. Therefore, du over 10x equals dx. Now that's going to allow me to do two things. It's going to allow me to substitute u in place of the BLOP, and it's going to allow me to substitute this du over 10x in place of this dx. So I rewrite my problem. So this time I have the integral, and instead of 5x squared plus 4, I'm using u to the fourth. I still have times 10x, but instead of having dx, I have du over 10x. Now when I look at this, I should see a couple of things going on. The first thing is that if I have multiplying and dividing by the same value, those are going to cancel. So the 10x and the divided by 10x cancel. So now what I actually have is the integral of u to the fourth du. And I know how to take that antiderivative. I know that I'm going to have a u with an exponent of 4 plus 1, so that's 5. I'm going to divide then 1 over 5, so that's 1/5, and it's an indefinite integral, so I add c. So for my final answer, I'm going to replace u back with my BLOP. So I'm going to have 1/5 the quantity 5x squared plus 4, replacing my u, to the fifth power plus c. And that is my indefinite integral. Okay, we're going to do one more example. This example is going to have a trig function in it, because I know that it's everyone's favorite. When you're given the trig functions, sometimes it's not nearly as easy to find the inside function. When you can't find the inside function, you basically just have to try again using a different inside function. However, with this problem, because there is an exponent to the fifth power, I'm going to try for my u to be sine of x. That would be my inside function. So I set u equal to sine of x. I take the derivative of u, so du equals cosine x dx. I then need to solve this for dx by dividing by cosine x on both sides of the equation. And I'm left with du over cosine x equals dx. So now I'm going to replace sine x with u, and I'm going to replace dx with du over cosine x. So we're going to rewrite our problem. We're taking the integral of cosine x, and then I'm replacing sine x with u, and that would be u to the fifth power, and I'm replacing dx with du over cosine x. Once again, I'm multiplying and dividing by the same value. So cosine x and cosine x cancel. And what I'm left with then is the integral of u to the fifth power du. So the integral of u to the fifth is 1/6 u to the sixth plus c. And now I can substitute and replace sine x back into where the u is now. And my indefinite integral is 1/6 sine x to the sixth plus c.